Well, the study I would like to present to you is a study done with a partner, which is IHS, and which main specialty is to forecast motorization at world level for the future. And we found out there were changes. And I helped them to take into account these changes that occurred especially at urban level. Well, the changes, we've seen them in the newspaper. There have been new toll systems in some cities like in Stockholm or London. We've seen them in the fact that we found out that younger people were delaying the time they get their driver license in mature markets, in mature countries. And they are delaying it either because they have other means of transportation, either because they can't afford it. We've seen also that younger are growing up with more green value than older generation. They learn sustainable development at school, and eco appliances are obvious to them. And it's obvious to them it's the right thing to use or to do. And we've seen change in the fact that we noticed that in some countries, here in Europe, we've seen car mobility decreasing at global level. But looking closer at the data, we found out that it was mainly because of urban transportation. Car mobility was declining in many European markets, but not only. And it's the reason why, to start this study, we look at 21 model cities to find out what was going on. And we look for data for all these cities. We look at them for, those are the 21 model cities we studied in non-OECD or OECD country. And we found out that also motorization is still increasing very fast in non-OECD cities, in Western European cities, always as in Tokyo or as in New York or even Los Angeles. Motorization is declining. It's declining not only at core urban level, but it's also declining at metropolitan level, which includes the suburb, of course. At the same time, we found out that virtual access, internet access, as well as mobile phone ownership has been gaining shares very fast. And in fact, we found out that internet access was almost at the same level in some Indian cities like Bangalore as in Western cities. We also had interviews in all these model cities with urban planners, with mobility experts, and we found out that all the cities we looked at as congestion issues, because those were large cities. And information technologies were developing for all these cities with different purposes. First purpose is generally to give more information about real-time connectivity for mass transit, for example, or for traffic jam. But it also develops to slow down car traffic and to give priority at traffic light for mass transit. Although some planners told us they were using information technology to ease or to make car traffic more fluid, it generally means that they are slowing down car traffic to have a better use on infrastructure. We also found out that most cities took action to reduce congestion. Some cities do it, I would say, the classical or the old ways by adding more roads, more parking, and improving the mass transit offer. But most cities, even in developing countries, are what we call active city, active in terms of regulating car traffic. They are using incentive to reduce car traffic within the city, which can be adding toll roads or congestion charging, but which can be also playing on urbanism to reduce car traffic, reducing space allocated to cars, reducing road space, and reducing parking. So once we studied all these model cities, what did we do? We tried to use all this, everything we learned, to forecast for 1,700 cities in the world. And instead of forecasting just real wealth and population. In this forecast, we use also urban densities and regulation that we observed in many cities. In fact, we discovered that motorization was self-limiting in dense cities. But of course, urban density is not the same in the different regions of the world. So the caps or the limits of motorization couldn't be the same for the different cities in the different regions. And in fact, the caps assessed were based on facts. For example, the 300 cars per thousand in Asia is just 300 cars per thousand is just the limit observed in a city like Tokyo, where it started declining. Of course, when we found evidence of regulation toward car traffic, we lowered these caps of this limit in the forecast, in the model. That led us to a new urban mobility scenario, taking into account the urban factor into the motorization forecast. And the results are here. And it lowered the car park by 13% in the time frame of 2035, taking this urban factor into account. Of course, if people use less their own car in the cities, they have alternative ways of moving around, as shown here in some of the model cities we used. But in the classical way to present modes, people don't take into account, not yet, virtual mobility, virtual access that can avoid trips, and car sharing schemes or other sharing schemes. In fact, technology improvement and virtual access change things. Mobile connectivity can reduce the need of physical trips, but it also allows other use of classical modes, like more shared use of classic modes, allowing new operators to come in between mass transit and car manufacturers, sharing operators. It, of course, if you share a car, it, of course, reduces the number of vehicles needed by each household, and it also expands the choices for each user, the mode choice for each user to go around in the city. In fact, this study allowed us to increase or to speed up the car sharing penetration in the cities between the time frame 2020 and 2030, to increase it by something like 50%. Here are just the number of car sharing schemes in the different cities of the world. From a car point of view, the mix of virtual access and the physical product that is the car made the product evolve. First, 15 years ago, it allowed the car to be connected with something here. The example is the OnStar by GM, the connected car that gives you the information. Nowadays, we are on a new scheme where the product of the car can be shared, and it gave room to new operators, even new manufacturers like Bolloré, with a car share Autolib feature. And we think that in the future, if there's a future for the car in the city, it might be something like the self-driving car once the car is fully connected. Of course, the self-driving car is not ready yet. There are still some technical issues to solve. There are still some legal issues to solve, especially for responsibility. But we know that many functions of the car product have been automated already. And we expect that the full self-driving car would be available by 2030, and probably at a cost of something like $30,000. Then it would be available for use, as well as a car sharing scheme, as a personal scheme. Then it leads us to this big picture of car within the urban mobility. In the past, it has been a product, and the mobility service was more mass transit, rental, or taxis. Now, and emerging, application and virtual access allows a more shared use of car, bikes, and other personal things as well. And I would say, short-term issue is to have an app that would give the user all the modes that are available for each trip. Nowadays, we have many apps, but there's no fusion of all the apps to give you all the choice for mobility. And we think in the future, if the autonomous car comes out, it might replace as well taxi, car sharing cars, be a complement to mass transit, and in some cases, be a mass transit vehicle. Thank you very much.
Thank you, Thank you, Véronique. Next speaker will be Albert Remke from 52 Degree North Initiative. Albert is Managing Director of 52 Degrees North Initiative for Geospatial Open Source Software, an international R&D network with partners from research, industry, and public administrations, aiming to foster innovation in the field of geoinformatics by organizing a joint OSS software development process. Albert, please.
Thanks for this introduction. Thanks for inviting me to this great conference and to present our thoughts and activities and ideas and to discuss this with you. So 52 Degrees North is an R&D network. There are a number of universities involved, University of Muenster, the University of Twente in the Netherlands, University of Muenster in Germany, some more universities in Germany, Technical University of Dresden, University of Applied Science in Bochum, some companies like Israel and Conterra, and public authorities as well. And the idea is to have a joint table where we're working on innovation in the field of geoinformatics. So it's an open innovation process we're fostering, and we're working on certain fields in the field of geoinformatics, and one of this is citizen science. So what's citizen science? What's citizen science about? It's about the participation of citizens in scientific research. So what scientific research is about identifying the research questions, reading the literature, developing theories, choosing methods for evaluating these theories, then doing experiments, observations, measurements, and then to analyze the data, do interpretations, and then publish these things as to discuss openly, well, if the findings and the conclusions were right. So where comes the citizen into play? And actually, in all of these aspects of scientific research, but where citizens can contribute most, that's in the field of experiments, of observations, of measurements, because there are so many people spread over the world being able to watch, to sense things, to think about things, so they're able to really do complex tasks as to understand what's out there. And this is fueled moreover through mobile technologies, supporting communication, supporting collaboration, providing more sensors to take up things. So this is really a unique capability of the crowd to provide information and contribute in this way to scientific research. So we're doing research in this field, and we're from the geoinformatics field of work, so we're more technology driven actually, and we're doing projects. One is the one I would like to present here and discuss with you. It's EnviroCar, and it's a project in the field of mobility and environment. And well, the background is, and this is what we're discussing at this conference in depth and detail, well, the tension between mobility and environment. So in Germany we have about 52 million cars, 46 billion liters fuel burned every year, and 158 tons of CO2 emitted every year. And it's clear that well, this challenge of developing mobility in a more sustainable way is something where you have to involve all societal groups. So the industry to develop the low emission technologies, science to help with this, science to help governments in developing new concepts, in how to organize mobility in urban areas, and what's the role of citizens? Citizens decide every day what to do. So to take the car, not to take the car, to take public transport, perhaps to buy a new car, to invest into low emission technology. And so citizens are deeply involved in this, and the question is how to get citizens on board when thinking about these things, and how to invoke change in mindsets as well. So the idea is with citizen science that we're able to engage citizens in the scientific work and jointly deal with questions like what impact has your driving style on CO2 emissions of your car? How compare your emission statistics with those of other drivers? So questions you have perhaps when you're driving your car, and questions public authorities have as well. So what can we learn from a fuel consumption map where we don't look at the individual track and the driving style of one driver, but when we're looking at all of the people who are out there and are driving, what if we get a fuel consumption map which tells us where we have these spikes, where we have these hotspots of fuel consumption and hotspots of CO2 emissions? What can we learn from this, and can we take this information to improve our concepts? And what we did is we developed a smartphone app which is able to connect and to talk to cars using an OBD2 Bluetooth adapter. And all cars since 2003 are equipped with this technology, and so the data is openly available. The data is fed back to the driver, so you can learn about your driving style, about your statistics, and the driver has the possibility to opt for publishing his data as open data. So he can upload the data to a server, and there's a simple REST interface so that other systems and users can take the data and work with the data from a scientific perspective, from a governmental perspective, and for personal interest as well. So, and there's a website which provides you with access to your data, and you can invite friends, access groups, and compare your stats with those of others. And the server is able to forward the data to other recipients. So you could subscribe for a data feed. And in this case, we used a feature manipulation engine from Safe Software and is right technology as to take up the data and provide not only the data as raw material, but derived information, put this into the cloud. So it's available in terms of interactive maps. And this is an example from the local authority of Muenster and a speed map. So you can just collect the data and have it readily available. So if you use this app and the car and upload your data, then it takes 3 seconds that it's available for the whole world. So this cloud platform is available for worldwide use, and you can start up activities at any point on the world right now. An example for an analysis is a CO2 hotspot analysis, and this is something we did with the first tracks in Muenster, and was very interesting to see that even with a low number of tracks when we started with this, it was possible to see interesting patterns in this, patterns in a spatial and in a temporal sense. So what you see in red are the hotspots in this case, and so some of these things were clear, so you know more or less where congestion zones are, but some of the things were not as obvious. And this is an example where we see on the left-hand side yellow marks tracks and measurements which came in on a road which is a central entrance to the city center of Muenster. And well, it's no hotspot. It's okay. It's a 70 kilometers per hour speed limit there, and a lot of traffic on this road, but it seems to be quite okay. And on the right-hand side, we see a living area in a 30 kilometers speed limit zone, and it's a bypass for people who like to speed up a bit or take for their direction, and so they take this road. And the question is, with this 30-kilometer speed limit, why is this a hotspot? And if you look into this, you see that there are speed bumps, so people have to slow down and then after the speed bump accelerate again. And this acceleration is let's say the fuel expensive activity there. And this makes this road a hotspot, and it was not obvious in the beginning. And this came up with the data we were able to collect in this way. So, what are the conclusions? Counted with 12 minutes. What are the conclusions on this activity? Well, Envirocar is an open platform for collaboration of citizens, scientists, and urban planners. And that's an important thing. So get people engaged, get to one table, being able to discuss these things, being able to develop a more comprehensive understanding of what's going on. And and as you know, knowledge and understanding precedes change to enable changes, which are changes in mindsets, and for all participants in this. Then it creates a unique and valuable source of open data. So right now we're still at a beginning of this activity. So we developed this technology over the summer semester with students at the University of Muenster. Then it took about 2-3 months to consolidate the software and make it really something you can bring out to a large group of users. And we published this in October, so we're still at the beginning of this. But you can see that, well, with a developing community of users, and you get really a unique set of data which is openly available. And it creates awareness, it creates understanding, and that's our assumption when going for this. This changes attitudes, and this changes behavior, and changes decisions. So I think it's an important point. So it's ready to go. As said, we're at the beginning of this, and what we're looking for is for partners, for local authorities, for research groups which are interested in this approach, not only in the technology. We're interested in the data, the information you can derive from this, and we're interested in launching citizen science projects with citizens in a certain area. And the technology is ready so that we're able to show and openly discuss the results of such projects on a global level, because with the cloud technology we're using, there's one common platform for all of the results, and so it's a joint activity which can be spent around the globe. So we're excited about this. I hope I brought the message to the audience, and very interested in the discussion we have. So these are the partners.
Thank you, Albert. Next speaker is Adam White from Group Shot. Adam founded the design firm Group Shot, where his work includes an effort to understand technology in informal settlements and developing cities. He has researched topics ranging from transportation to redevelopment for the Olympics in Beijing and London.
Good morning, everyone. My name is Adam White, as he said, and I'm the principal and founder of Group Shot. I mostly have been looking for the last few years at the intersection between technology and communities, and how different communities use technology. And I usually describe it as a mixture of a little bit of anthropology and sociology with technology. We've had some good sort of overviews, and I am curious to chat more about the projects in the Q&A. But I am going to focus on a particular practical example on a project that I've been working on for about 2 years in Nairobi. And what we've been trying to do is map the Matatu system. And I'll give a little background, and then I'll get into the details of the implications of that. So far, there's been a lot of talk over the last few days about a smart city, and it usually has a particular image of a cleaner city, or a city that's more green, or a very network city. And Nairobi maybe doesn't fit that image in a lot of ways, although maybe behind the surface it does. It's a city of more than 3 million people, and it's also a relatively spread out city. So except for the central business district, which this is a photograph of, a lot of people live in a fairly low density area. And then there's also exceptions, which are the informal settlements, which are really high density. Transport in the city is primarily via matatu. 70% of motorized trips happen on matatus, and so matatus are usually small minivans like these buses here. They can also be larger buses, up to about a 50-seater bus. And this is a photograph of the central terminal, of one of the many central terminals in downtown Nairobi. The city is very centralized itself. And so a lot of people will come and work in the center of the city, or they'll come and transfer. And so there's a handful of terminus, and no bus routes will actually pass through the city. So every bus or every matatu will have to come into the center, and then you'll have to transfer to another one if you want to continue outside of the center. The matatu itself, each vehicle is owned by an individual. A handful of them are owned by collectives. If the driver's lucky, he'll be the owner of the vehicle himself. So it's all privately owned and operated, which is really different from a lot of the transport systems that other people are looking at, and is a little bit more like a shared taxi than other forms of transport. The operators of the vehicles, who are the drivers or the conductors, they'll rent the vehicle from the owner for the day. They'll pay something like 2,000 shillings or maybe $20, and then every profit that they make over that, they get to keep for themselves. So that encourages some fairly reckless driving behavior because you're trying to maximize your profit and get as many trips as you can in a given day. It also means that the system is highly demand responsive. I think it's interesting when you start talking about shared transport and community transport systems and apps that can help to do that. And then you look at a system like this, which is demand responsive at its core, and it leads to some strengths and weaknesses. It's a collaborative system, and in some ways it's very smart. There's no vehicles that are going out that aren't entirely full. If, for example, everyone on the vehicle agrees that they just want to go straight to town, there's no reason for the vehicle to make every stop along the way. It'll actually take a shortcut and go straight there. And so in some ways it's very smart. The system is technically regulated. It's legal. It's not illegal. It's the only form of public transport in Nairobi, and so it's semi-regulated in that respect. So there's a handful of things that users have to meet, but it still has sort of the DNA of an informal system, in that the routes are never set. The routes change over time. If you look at this is a vehicle that operates on Route 2, which they just sort of decided would become a route, and the routes are constantly changing and evolving. And I just want to talk a little bit about a couple of the strengths and weaknesses of the system really quickly. First of all, like I said, because there's so many vehicles and they're operating so frequently, there's often no wait at all for a vehicle. You might put up your hand and within 10 seconds or 30 seconds get on a vehicle going exactly where you want. They can take shortcuts, they can be responsive. They're a very human way of transporting, and they also have a lot of resilience built into it. But there's also a lot of weaknesses. So first of all, it can be incredibly unsafe to travel in this way. There's a lot of accidents. Sometimes the drivers could be intoxicated. There can also be violence or crime on the vehicles. They're also not dependable. And so in some days when you might wait 30 seconds for a vehicle, you might also have your hand up for 30 minutes and every vehicle that goes by is full. Or on a rainy day, for example, the fares might skyrocket tenfold what the normal fare would be. They also can be quite unpleasant, or they can be fun, depending on your perspective. A lot of them will have loud music or TVs. Some of that was outlawed in 2006. But this is the way that most people get around in Nairobi. And it's responsive, and maybe it's responsive to a fault. And so another interesting story that you'll hear very often is that you're on a matatu, you're heading out of town, there are only a few passengers on the vehicle, and the drivers notice that there were a lot of passengers who wanted to go into town, so they'll kick you off, they'll put you on another vehicle going out of town, they'll turn around and they'll pick up a load going back into town. So again, they're maximizing the usage of the system. So the initial problem and the way that we looked at this is that this is an illegible transport system. As an outsider in particular, it's very hard to make sense of what's going on. But even as someone who lives in the city, you only know little bits about the system. There's no map of the system at all. So the government, which semi-regulates this and licenses a lot of the vehicles to operate, they have a stack of Word documents that list where some of the vehicles are supposed to make turns. But there's no official map and there's no geographic data related to the system, or at least there wasn't. The system, as I said, it's changing. It's constantly changing. And so in the process of mapping the system, we've already noticed about 1 or 2 new routes that have come up just in the time process that it's taken for us to collect some of this data. Now, to give a little bit of context about Kenya and why we started to bring technology into this, a lot of people are talking about the role of technology and mobile phones in Africa in general, and Kenya is definitely one of the leaders in this. It's estimated that at least 70% of Kenyans have access to a mobile phone, and realistically in Nairobi, everyone has access to a mobile phone. Interestingly, it's also approaching about 15% or more that actually have access to Android. So this is more than feature phones, this is smartphones, which is again changing the data that you can collect from citizens and also changing the data that you can push back. Additionally, Kenya has a new constitution which includes a right to open data for citizens. And so as a result, the Kenyan Open Data Initiative, ODK, is pushing out a lot of government data, and so there's a growing attitude about data. Now, this attitude of open data tends to come from mostly the technology community, and so it's not necessarily spread to everyone, and so that's important to consider. So there are a series of apps or hackathons, and there's a range of initiatives, but there needs to be more if you want to get open data to reach more citizens and to reach them differently, and that requires sometimes partnerships with technologists, but that also requires pushing technologists to think outside of their comfort zone. The technologists that I work with in Nairobi are very similar to the technologists that I work with in Boston or San Francisco. And then in addition to that, there's a growing push for technology innovation in Nairobi in general. I would say there's a combination of government policy, which has made Kenya a very technology-friendly country, as well as a handful of early entrepreneurs which have developed sort of a technology hub and ecosystem in particular neighborhoods in Nairobi. The phrase that's being thrown around is Silicon Savannah. And so in this particular neighborhood, there's over 100 startups. A lot of them are learning very quickly about what works and what doesn't work. A lot of them are replicating foreign startup concepts. And so there's a quite lively group of technologists. And so the stage is set for the project that we embarked on. On one hand, we've got this problematic transit sector. Then on the other hand, we have a growing opportunity for technology to interface with a lot of different citizens via SMS and mobile, via technologists who are going to develop apps, and via government, which is also quite open to technology. So our team, we were funded by the Rockefeller Foundation, and it was a team of partnership with myself, as well as the University of Nairobi, who was the main lead in Nairobi, the Center for Sustainable Urban Design in Columbia, and the Civic Data Design Lab at MIT. And what we did was we set out to collect the most up-to-date data set about all of the routes, and in the process, I did a lot of research relating to how this data could influence the system. I looked at a lot of the different examples of both technology and non-technology projects which have tried to proliferate into the Matatu system, and that gets a lot into the design and user-centered design questions, which I'll hint at a little bit, and we maybe can talk a little bit more about the questions. And what we developed was the first open access map of the Matatu system in Nairobi. It's also the most complete and the most public map that's ever been created of the Matatu system, and it's also one of only a handful of cities that have this sort of informal or paratransit system to now have a comprehensive map like this. And if you zoom in, you can see right away that it's a complex map. There's a lot of routes that operate on the same corridors. There's a lot of routes that are very subtle in the differences. You can see here, this is the box that I didn't zoom into, is the central core, and so you can see there's a number of terminals right there, and none of these routes circle or connect anywhere between those. There's no circle routes that go around the center. Everything is very centralized. And like I said, the government doesn't have any map of this, and so at the moment, the government is, with help from China, is investing really heavily in brand new highways. There's also a project starting to build a BRT system. But before this map, the public transport data that these decisions are based on was 10-year-old data that had been extrapolated year after year after year on very limited household level surveys. And so the reality is that a lot of the decision making was ignorant of the existing public transport system. So this is the data visualization that we created, and a lot of people have been talking about data visualization over the last couple of days, but the reality is that visualization is probably not enough. In this case, it's definitely not enough. And so the reality is that behind that map is a GTFS data set. Just out of curiosity, is anyone familiar with GTFS here? All right, so only a couple of people. So GTFS is the General Transit Feed Specification for any public transport agency to publish their transit data. It was originally created with Google as the Google Transit Feed Specification for the city of Portland, Oregon. And when Google released its public transit data for Oregon as the first city, it came through this type of feed. It's mostly CSV documents or open documents that transit agencies will publish on their websites. It's a schema of how, a schematic of how this transit data interacts with each other. And interestingly, the GTFS community is a group of people who agree on the standards rather than a particular board that sets the standards. And so for a standard to get changed, one or two organizations need to start using it and then implementing it in that way. But the GTFS data structure is problematic when it comes to a city like Nairobi because it makes a lot of assumptions about a particular agency or even that the system operates on a set schedule or set routes when at times the routes might change or there's a degree of paratransit that's infused into the system. And so we started by making some simple changes to GTFS, which are now trying to proliferate throughout the GTFS community so that we could have our data be open and as accessible as these other projects, use existing tools that are already on the market to use GTFS data, such as open route planners, and then also ourselves begin changing the discussion about how transit data can relate to more dynamic systems and more informal systems and emphasize some of the strengths in those systems. And from the very beginning, this project was a collaboration. And so the way that we've been fostering a huge network of supporters from the government, from research groups in Nairobi, to technology partners, as well as direct citizen portals. So from an API that we've developed, and we've already got 2 or 3 startups in Nairobi that are using it. We're also working with Google to get our data to be the first city like this to be represented on Google Maps and public transit. We've also worked directly with the government to see this immediately influencing public planning decisions about investments in road and where the BRT system could go. And then we've also been reaching out to the operators themselves to see how they can use this data to improve their routing and improve the service that they're offering to the commuters. And then through those channels, we're also, in general, improving service for all the commuters, as well as creating some citizen-focused apps like the map. And so the key to the sort of next step that we're looking at now is getting into the maintenance and how does that maintenance get owned by individuals, by groups? Is that crowdsourced? Is that something that's related directly to the government? And that's a longer discussion and something that I'd also be happy to chat about in the questions. And so the key to all of this is a lot of questions about design. And design can relate to the visualization of the way that this is represented, and it also relates to the individual tools. And deciding to use SMS because you can push information in a particular way to a particular group of people is an important decision that a project like this can make. And as a network of a lot of different partners, some of those partners being app developers or people who are working with citizens directly, we don't have to make all of those decisions. And so that's a very helpful asset for us. And this, just very quickly, this is a map of Kibera, which is one of the largest informal settlements in Nairobi. And this is a very different map than the style of map that we created. This was painted by my friend Isaac, who's the sign painter for the Matatu system, who paints the route numbers for the signs. And so his perception of his neighborhood is very different. And so if I want to develop an app for him, it may not look like the same app that I might use for San Francisco. And so just to kind of conclude, when I think about technology in cities, I like to think about lightweight infrastructure, an infrastructure that can go on top of or complement or push out the best in existing systems. And I think that technology, particularly IT, has a big role to do that. And just to conclude, last week we hosted a session with about 30 different cities that were represented called GTFS for All, where we brainstormed how we can push GTFS to be more valuable to a different type of cities. We had Dhaka, Mexico City, Jakarta, Nairobi, and we all sort of discussed the standards within GTFS as well as the additional tools and other things that we can bring public transit data to more people, to all citizens, and make smart cities for all. Thank you.